Now that we kind of understand the theory behind confidence intervals and hypothesis tests, the next few videos are going to go into actually how we calculate the values used in a confidence interval and a hypothesis test. The first thing we're going to look at is doing a confidence interval for a proportion. And to find a confidence interval for a proportion, the first thing we need to know how to find is the critical value for that proportion. So that's what we're going to look at in this video. The idea of finding the critical value is we're going to be looking at a normal distribution, which has some average for the proportion, the sample proportion we'll call p hat, and the confidence level tells us what percent of proportions we want to fall in the middle on both sides of the proportion. In other words, we're going to have the proportion plus some error and the proportion minus some error. That's that net that we're trying to throw around the proportion. And what we're really interested in is this area in both tails. That area in both tails is often called the alpha. Both of those together are called alpha. And the way we can find that alpha is actually on Excel. We can type in equals norm dot s, because it's always going to be a standardized alpha level, dot inv, and then we'll put in whatever alpha divided by 2 actually equals. Because alpha is both tails together, and we only want one tail, because the norm.s.inverse will give the left side of that left tail. And so we're going to do alpha divided by 2. So what this looks like with an example is if we want to find this critical value for a 92% confidence interval, for a proportion, what we'll do is we'll say, OK, if I were to draw a picture with my sample proportion in the middle, we want to be that sample proportion minus an error to the left, or that sample proportion plus an error to the right. We want to be in the middle of that. Well, if we want to be 92% confident, that means 0.92 is in that blue area. The alpha then, the area in the outsides, would be what's left when we take 1 minus 0.92. This gives us an alpha of 0.08. But that 0.08 is split up equally on both sides. So half of alpha, alpha divided by 2, is 0.08 divided by 2, which gives us 0.04. There is 0.04 on each side of that distribution. That 0.04 is what's going to go into the norm.s. Norm.s.inverse command. And we'll put in that 0.04. And when I type that into Excel, Excel's going to tell me that that is about negative 1.75. And generally, Excel's going to give us a negative value. We're actually going to ignore the negative, and we'll just say that the critical value is the positive version, the 1.75. So Excel can really quickly give us that critical value if we draw the picture and figure out what alpha over 2 is and do it on Excel. However, there are some critical values that are very common in statistics. And so we might want to just list out some common critical values that we can just look up in a chart. So if I want a confidence level of 90%, that's one of the most common confidence levels. The critical value, which we show as z alpha over 2, the critical value for 90% comes out to be about 1.645. If I want a confidence level of 95%, the critical value there is going to be about 1.96. And the other common confidence level we'll see is a 99% confidence level, which has a critical value of 2.576. So if we have one of these common confidence levels with a proportion, we can just use this chart rather than looking it up. If it's not a common number like the 92% we just did, we'll quickly draw a picture, figure out what the alpha over 2 is, and plug that into Excel to find the correct critical value. In our next video, we'll look at how these critical values help us calculate the error, or the size of the net thrown, to calculate the confidence interval.